Okay, question 6 is quite a sneaky question. It says we've got a triangle and we've got a sector at the top here. We're interested in the triangle for the first couple of parts of this question. It says find in radians the obtuse angle BAC. Now I think they've been quite, well, they've had to tell us it's obtuse, but that should ring alarm bells. We've got a known pair here, so we're about to do the sine rule. Now when we, on a calculator, when we inverse sine a number, we always get the first answer from the cycle, from the loop, which hopefully you remember is always going to be less than 90 if we're talking acute degrees, but because we're talking, I'll write pi over 2 here because we're working in radians. So if we inverse sine the number, we'd get this angle here. We're interested in the obtuse angle, the angle that's between pi over 2 and pi. So we need to be careful of that. We need to make sure that we sort that out when we come to need to do it. But it's worth noticing that at the beginning of the question so that you're ready to cope with it later. So it's just a straight sine rule question. We're going to do the sine of BAC over 10 is going to equal the sine of pi over 6 over 7. So the sine of BAC is going to be 10 sine pi over 6 over 7. Need to go back to radians. So 10 sine pi over 6 divided by 7 is 5/7. So if we now inverse sine that, that will get us, not BCA, BAC, but it will tell us an acute angle. We don't want that angle. That is the angle for my graph. That's this angle here. In order to get the one we want, we're going to need to take that 0.796 away from pi. So BAC is actually pi minus that 0.796. So BAC in radians is 2.35. How many? Well, it's 4 significant figures. 2.346